Alrighty, 2.3, graphing equations in slope-intercept form. Now, I've been asked by a lot of students to try and please make these videos more informative and long and tedious. So, that's what I'm going to try and do today. We're just going to kind of try to go as monotone as possible and as boring as I possibly can make it, just because I want to do what you need. Okay. Um, so, oh man, sometimes I forget that that no one is gonna listen to this for a very very long time, and it could very well come off um, uh, completely wrong, and you don't understand my sarcasm. Uh, but then again, at the same time, I'm having fun doing it, so who cares? 2.3, here we go. We've looked at these equations. We looked at like the parallel and perpendicular, the slope, but we haven't really looked at how an actual equation relates to a specific graph. We plotted points before, but that was pretty much the extent of it. So what we want to do is actually look at specific types of equations and how those equations are laid out, and then how to graph certain things and how to interpret the graph, more importantly. So first we need to look at some vocabulary. The first part is X-intercept. And the X-intercept of a line is the X-coordinate of a point where the line crosses the X-axis. It occurs at this point. It occurs when the Y value is 0. Okay, it occurs when Y equals 0 at this particular point. The same thing is going to be true for the Y-intercept. That occurs, it is the Y coordinate of a point where the line crosses the Y axis. And it occurs when the X equals 0. So in a coordinate where it's 0, comma, some number. Alrighty, so now with these ideas in mind, let's look over this image here. We have a line that's passing through. We have these two places, one where it intercepts the y-axis, one where it intercepts the x-axis. So this y-intercept happens and will always have an x value of 0. That's a very, very important thing to remember. And that the x-intercept will always have a y value of 0. And it's something that comes in very, very handy when we start trying to solve some of these equations. So now let's look and use this information to look at slope-intercept form of a linear equation. So slope-intercept form is written as y equals mx plus b, where the m represents the slope like we had done before, and the b represents the y-intercept. Okie dokie. So now let's kind of put that into practice. Let's look at some of these. Find the slope and y-intercept of the graph of each linear equation. So I need the slope and the y-intercept. If I didn't know that this was in slope-intercept form, I would have to graph it. It would really be my only way to try and find that information. But because I know that this is written in a way that it says y equals mx plus b, I can pull some very important information out of there, like the y-intercept and the slope. This value right here that's attached to the x is m, or slope. So slope equals m, which in this case is a -4. The y-intercept now is a little bit trickier, and it's only tricky in this case because it says -2, when up here we have plus b. So what that's telling me is that this originally should have said -4x plus -2, which just becomes -2. So the y-intercept is at -2, or the coordinate point 0, comma, -2. Alright? Because I know that the y-intercept will always have an x value of 0. Now let's look at this one. we want to find the slope and the y-intercept. Now, is it in slope-intercept form? Because if it is, it's going to be super easy for me to get that information. Unfortunately, it's not quite there. Slope-intercept form says that y is by itself. Y equals mx plus b. Here, I have y minus 5 equals. So let's just try and move that over and see if that does it. I'll add 5 to both sides to keep it balanced. Then y equals 3 over 2x plus 5. There's no like terms that I have to combine here. They're just completely separate. And yeah, now it looks like it says mx plus b. So the slope is m, which is 3 over 2. And the y-intercept is going to be 5. Or the coordinate point 0, comma 5. Very, very good. Now let's see what else we got in store here. Graph a linear equation in slope-intercept form. I knew it. I knew it couldn't be as simple as just taking little bits of information out of the equation, something so simple like that. But graphing in this case is going to be so much simpler than inputting x values and then plotting points. When we have a situation like this, I'm just going to set up my coordinate plane here while I talk. When I have a situation like this, there's a different method for graphing. I don't want that to be blue. A different method for graphing that makes it quite easy. If I were to take some points, some relevant pieces of information from this equation, I would say that the y-intercept is 3 and that the slope is negative 3. With that, I can plot at least one point right off the bat. My y-intercept is 3, which means at 0, 3, so 0, 1, 2, 3, there is a point. And I know that the graph will go through that point. Now, all I have to do is kind of trace. Right? I know that the slope is negative 3. I know that that means that it's going to go down 3 and over 1. Down 3 and over 1 in the negative direction. So if I were to now draw a line to connect those two, that would be my equation line. That would be all that I would have to do. I could continue making points if I had made my coordinate plane a little bit bigger. I could go 3 and over 1, and the line would continue, and I could go over and down 3, and the line would continue, and over and over and over and over again. So graphing using slope-intercept form actually cuts the time dramatically. So now let's look at an application problem, and we're probably going to have to graph again using that method. So we have the cost y in dollars of taking a taxi x miles and an equation that represents it. So y is the cost, x is how many miles you're going. Okay, so cost related to how many miles. We want to first graph it. Alrighty. Let's just go ahead and make my x and y axis. Very good. And then I'll plot some points. I know for a fact the y-intercept is 2, so I can plot that point at least. And then I also know that this is 2.5. What's another way of writing 2.5? How could I write that as a fraction? 2.5, 5 over 2, which means a rise of 5 and a run of 2. Rising 1, 2, 3, 4, 5 over 2. Now, is it also possible that I could have just said 2.5 over 1? Yeah, absolutely. I could have gone over 1 and up 1, 2 and a half. Over 1 and up 1, 2 and a half. And I would have gotten right to where I was. Either way is fine. But now I have a couple of points here that I can connect and create my equation line. And everything looks fantastic. So now, what's the next thing that I have to do? I've graphed it, now I have to interpret the y-intercept and the slope. Interpret. That basically means it's not telling you what everything is in this situation. It's saying, help me understand what that line represents in terms of the situation. Alrighty, so y was the cost in dollars, x was the amount of miles you're going. What could this 2.5 and this 2 possibly be representing if this is supposed to be an equation representing how much money you spend in a taxi for every mile you go? Well, let's take a look, see if we can figure it out. 2.5 is multiplying every single mile. So it's got to be something like $2.5 every single mile you go. So what that would be called is something like a rate. That's like a mile rate, 2.5 every single mile. But the 2 at the end is kind of just tacked on there. So that's it's plus 2 regardless of how many miles you travel. So the $2, the y-intercept, is somewhat of just like a flat initial fee to use the taxi just in general. So we're looking at this in terms of y-intercept and slope. So y-intercept is kind of the lowest amount of money you could possibly pay in the taxi. Right? You could get in and you could go 0 miles, but you'd still have to pay $2. The slope is the rate at which that amount of money you spend is going to increase. Right? So when we say things like the rate of change or the slope of a line, those things are kind of interchangeable. As we can see here, that the slope of 2.5 is a rate. Alright, so that's the end of this. Work on the assigned problems. Again, if you have questions, make sure you write them down and we will work on them. Good luck. Yeah, cool. I'm going to go watch Saved by the Bell. See you later.